Hey everyone, it's Mrs. Olslager here. I'm going to walk you through how to find the surface area of a rectangular base pyramid. I'm going to go really slow. It's your first time seeing it, and I definitely would have tried to find a better published video, but there really isn't anything out there on the internet that uses the proper vocab and doesn't try to speed you through it. So bear with me. This is like attempt, I don't even know at this point recording this. I'm hoping this one is the success. So I have this rectangular base pyramid here, and starting off all of these, just kind of make a list of all the faces that you need to find the surface area of in order to get the total surface area. So my list here includes a rectangular base. So I'm going to find the area of a rectangle. And then I have altogether 4 triangles, okay? I have this triangle kind of to the front right, and that triangle has a base of 10 and a slant height of 12, okay? So I'm gonna need to find, and then it's mirrored over here, this triangle here. So there's 2 times triangles with base of 10, and then the third face that I need to find the area of is this nice front left, okay? That's with a triangle with a base of 14, and that triangle is gonna be the same as this triangle, okay? So we're gonna go 2 times triangles with base 14. All right, so let's go ahead and find all these values. The first one, the rectangle, is super easy, right? That's just gonna be 14 times 10, which gives me a base of 140 units squared. Okay, for kind of this this yellow highlighted triangle here, they give me all the information I need to automatically go ahead and be able to calculate the area. They give me the height of 12, it's a slant height that's perpendicular to the base of 10, okay? So remember, that's like sliding down the triangle for finding the area of this front face. I'm just gonna draw it separate to make it more visually clear, right? So that triangle, the slant height sliding down here is 12, and then you have a total base of 10. So I'm gonna split that into 5, okay? So that kind of helps with that picture of finding the area of this triangle. So the area here then of one of these triangles would be 1/2 the base, which is 10, times 12, okay? Well, half is 5 times 12 is 60. So the area of one of those triangles is 60 units squared, but not only do I have the front triangle, I also have the one in the back. So we're gonna multiply that by 2. So those 2 triangles have a total surface area of 120 units squared. All right, that's kind of the easy run through of those. Then it's the tricky, where you have to use the information given to find the area of the last 2 faces. All right, and so I have missing information. I have a base of 14. I know that gives me this little piece of 7, but I need this slant height of this last face in order to find total surface area. All right, if they had said giving me the height of the pyramid, my triangle would look a little different, and I'm gonna go through that example next. But here, the only piece I can use to help me and get to is this nice lateral edge, right? Because I have this highlighted yellow triangle on the right to help me find our lateral edge. All right, so I'm just gonna draw a sketch of that yellow highlighted triangle. That yellow triangle has this base of 5 with a height of 12, and I'm finding that hypotenuse because it's across from this right angle here, okay? It's a nice Pythagorean triple, so 5, 12, 13, okay? So this highlighted segment is 13 units, all right? Well, finally then I can get my slant height to do angle by using this pink triangle to do Pythagorean theorem. So I'm gonna draw that triangle separate. I have across from this 90-degree angle is the 13. This piece is 7, so I'm gonna do Pythagorean theorem to get the slant height of that pink highlighted triangle. All right, so we have x squared plus 7 squared equals 13 squared. Not as nice that it's not a triple, but that's okay. We're gonna make do. And I'm gonna subtract 49. So I get that x squared is equal, blah, 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 blah. Oh my gosh. You know when you're like on the spot on a video and you just can't even mentally process that in your head? Okay, duh, 120. All right, square root, square root. All right, simplifying 120. If we can keep this in exact form, we definitely should, instead of bailing out to using decimals. So simplifying this radical, let's think about the largest perfect squares that'll go in there. We can definitely divide 120 by 4. Okay, so I'm going to break this into square root of 4, square root of 30. Well, then I see, okay, well, square root of 30 breaks into the square root. I can divide that by 2, but then I'm left with just 2 and square root of 15, and these guys can't simplify any further. So I'm just going to be able to simplify this down to that segment being 2 square root of 30. Okay, so 2 square root of 30 is this slant height. Okay, so now over here I can finally find my third piece and component, the last face in the area. So that triangle, this nice pink triangle, right? I'm going to draw it full scale over here. That had a full base of 14 and then a nice slant height of 2 square root of 30. All right. Finish up finding the area. Area is going to be 1/2 the base times 2 square root of 30. Okay. Simplifying that down, this just becomes 7, and so 7 times 2 is 14. So the area, that whole triangle, is 14 square root of 30. But then remember, there's 2 of those. So we want to multiply this by 2 for the 2 triangles. So that'd be 28 square root of 30 units squared. Whew! Okay. I have all of my 6 faces, and so now I can sum them. So I have the 120 plus the 140 is 260, and then plus my radical, which is 28 square root of 30. Units squared is the total surface area for this rectangular based pyramid. Okay, so a lot of pieces going through there. Pause and replay as much as you need to. Keep emailing us questions. I really hope this visual representation helps you guys tomorrow. Take care.